Hello, let's find the value of a, given that our a does not equal to 0. Then solution from here, we have a to the power of 3 plus a equals 10, a to the power of 3 plus a equals, we can have this 10 as 2 plus 8. Then we have a to the power of 3 plus a equals, let's have this 8 in base 2, 2 to the power of 3 plus 2. You know, from here, one can decide that the value of a equals 2. But the reason why we are not going to divide at this step is that we are expected to have 3 possible solutions because the highest degree is 3. So let's regroup. By regrouping, so we are going to have a to the power of 3 minus 2 to the power of 3 plus a minus 2. We have a to the power of 3 minus 2 to the power of 3. Let's have them as this. Plus, put parentheses, a minus 2. Then everything will be equal to 0. So from here, when you have a to the x to the power of 3 minus y to the power of 3, will always be equals x minus y times x squared plus xy plus y squared. So from here we have a minus 2 times a squared plus 2a plus 2 plus 2 squared plus a minus 2 equals 0. A minus 2 is common, so we can factor it out to be a minus 2. This will be a squared plus 2a plus 4, and this will be plus 1 equals 0. We have a minus 2. This will be a squared plus 2a plus 5 equals 0. Apply the 0 product rule, and that one says for this expression to be equal to 0, is either we have a minus 2 in parentheses equals 0, or we have a squared plus 2a plus 5 equals 0. So from here, if you define this to be case 1, and we define this to be case 2, so let's solve case 1. A minus 2 equals 0, then a will be equals 2. Now, from here, a squared plus 2a plus 5a equals 0. Solving it quadratically, we have a, this will be minus 2 positive or negative square root of 4 as 4 times 5 by 2, and this will be minus 2 positive or negative 4 into 1 and 5 by 2. So we have a minus 2 positive or negative 4 times minus 4 over 2. So we have a 4 squared times I over 2. We have A, and this cancel out this, we have 4I over 2. So A minus 2 over 2, positive or negative, 4I over 2. This will be 1 minus 1, positive or negative, 2I. So therefore, A equals to, or equals positive or negative, also equals minus 1 positive or negative 2I.